Well, let's apply our skills to solving exponential inequalities. And the key thing here is to get things to the same base. And let's work through a problem or two and we'll see what we mean. So we're going to start off with, we've got 3 raised to the power of 2x minus 1 is greater than or equal to 1 over 243. Well, I've got on the left side of this inequality, I've got a base of 3, but on the right side, I've got 1 over 243. Well, let's see. If I divide 243 by 3, that's 81. I'm on the right track. I know 81 is 3 to the 4th, so that must mean that 243 is 3 to the 5th. So now I'm going to rewrite this equation to where it is 3, base 3, raised to the power of 2x minus 1 is now greater than or equal to 1 over 3, base 3 raised to the 5th power. And I'm going to rewrite this again using my properties of exponents to read that 3 raised to the power of 2x minus 1 is greater than or equal to 3 raised to the negative 5th power. That negative 5th would put that down in the denominator. So when I move it from the denominator up to the numerator, then I've got to make sure that I include the negative so that it is consistent with what its value truly is. Well, now that I've got the same bases, I can cancel out the bases. And once I do, I've got 2x minus 1 is now greater than or equal to negative 5. And now we're just going to solve this just like any normal linear inequality. And so we're going to add 1 to both sides. And so 2x is now greater than or equal to negative 4. And then we divide both sides by 2 such that x is now greater than or equal to negative 2. Now I might want to think about going up there and putting that back into my original function on the left-hand side and see if this actually equals. So let's see, if I had then 3 raised to the power of 2 times negative 2, got ahead of myself, negative 2 minus 1, well, that's going to then equal 3 negative 4 minus 1, which equals 3 to the negative 5th power, which then equals 1 over 3 to the 5th, and 3 to the 5th is 243, and there we go. We have solved and proved that back, check my work, proved that back that I do that 3 times 2 times negative 2 minus 1 raised to that power is equal to or greater, is the equivalent of 1 over 243. Now to write that in set builder notation, I would say that we've got x such that x is greater than or equal to negative 2. All right. Good enough. Let's go look at one more. All right, this time we got something very similar. It's 2 raised to the power of x plus 2, and we're saying that that is greater than or equal to 1 over 32. Again, I've got to try to work to get these to the same base. Well, 32 is divisible by 2, and in fact, 32 is 2 to the 5th. So I'm going to rewrite this now as 2 raised to the power of x plus 2 being greater than 1 over 2 to the 5th. And then I'm going to rewrite that using that property of exponents to say that I've got base 2 raised to the power of x plus 2 is greater than base 2 raised to the negative 5th power. And once again, my bases, I can cancel those because I've gotten them to the same base. So now we got x plus 2 is greater than negative 5, and let's subtract 2 from both sides. And we've got x is greater than negative 7. And if I just pop negative 7 back up into that original function, 2 raised to the power of x plus 2, substitute negative 7 in for x. I got 2 raised to the power of minus 7 plus 2, that's negative 5. And 2 raised to the negative 5th power is in fact 1 over 32. And then closing this off with set builder notation, we're saying that x such that x is greater than or equal to negative 7. In other words, as long as x is greater than or equal to negative 7, 2 raised to that power of x plus 2 is going to be greater than 1 over negative 32. Excuse me, 1 over 32 or 1/32. Ma, where's the meatloaf?